11 challenges of sharding. Sharding is an effective technique for scaling databases horizontally by distributing data across multiple servers or multiple shards, but it comes with several challenges. These challenges arise from the complexity of managing multiple distributed data sources while maintaining performance, consistency, and reliability. Let's try to talk about them one by one. Let's make the text way more smaller and let's talk about them. So the first thing that we will talk about, which is the hotspots or data distribution imbalance. So one of the biggest challenges in sharding is ensuring an even distribution of data across shards. Poorly choosing shard keys can result in some shards storing much more data than others, leading to hotspots where some shards are overburdened while others remain underutilized. The impact of this one is that hotspots can cause performance bottlenecks as some shards become overloaded, leading to slower read and write operations for the users whose data resides on those shards. A solution for this one is that carefully choosing an appropriate shard key, such as hashed key, to distribute load evenly across all shards. And yeah, it's if you, in new system design interview, if your interviewer asks you about data distribution imbalance, you mainly should answer of that, okay, we should use a sharded key instead of just using like a price for products or time for I don't know, for users or emails or something like that. Okay, number two, it will be the complexity in querying across shards. And this one is big. So queries that involve data from multiple shards, like cross-shard queries, the definition of it, are more complex to execute than queries on a single database. The system must gather data from different shards, aggregate the results, and ensure that the query returns a consistent view of the data. The impact of this challenge is that cross-shard queries can lead to slower performance because a query must be executed on multiple shards, and network latency can also increase response can also increase the response times. Additionally, writing efficient cross-shard queries adds complexity for developer. I don't know if you saw before a cross-shard query; it's nightmare to look at. The solution for this one is that we can denormalizing data, avoiding cross-shard joins where possible, and caching the results for frequent cross-shard queries, and this can help mitigate performance issue. But we need to talk about this one really in details, and I guess I will need to create a video for each one of them. Number three, we have the rebalancing and resharding. So, as the system grows and new shards are added, data needs to be redistributed across existing and new shards to maintain balance. This process, known as resharding, and this one can be complex and resource intensive, especially in system with large amounts of data. The impact of resharding can disrupt the system during active usage, leading to downtime and involve significant operational overhead. It can also introduce data consistency issue during the migration process. The solution of this one is that automating the resharding process and carefully planning short key design in advance to minimize the need for resharding. Some distributed databases have built-in mechanisms to handle shard rebalancing automatically. Number 4, increased operational complexity. So managing sharded database is more complex than managing a single monolithic database. It requires the tracking multiple database instances, ensuring they are synchronized, monitoring each shard's health, and maintaining backups. The impact of this one, the operational overhead increased significantly as the number of shards grows, requiring more sophisticated monitoring, alerting, and maintenance tools. And the failure in one shard can cause partitional data loss or service disruption, leading to a more challenging recovery process. And the solution on this one is that using automated tools for shard management, backups, and monitoring can reduce operational complexity. Cloud platforms, I guess like AWS and Google Cloud and Azure, provide managed database services with built-in support for sharding for that. They can help us for this one. Okay, number 5, data inconsistency and transactions. In a sharded environment, ensuring strong consistency across multiple shards is difficult, especially for write-heavy applications that rely on transactions spanning multiple shards. Operations like multi-shard, the impact of this one is that operations like multi-shard transactions may require complex coordination to ensure data consistency, and without careful management, inconsistencies can occur. Many distributed databases sacrifice strong consistency in favor of availability and partition tolerance. And this is according to the CAP theorem, and we will talk about this CAP theorem. I guess we did talk about the CAP theorem multiple times in this channel, so feel free to check the playlist of the system design, the playlist here. So the solution for this one is that using a distributed transaction protocols like two-phase commit or like 2PC can help maintain consistency, but they come with performance cost. Alternatively, developers can design systems to tolerate even eventual consistency. Number 6, handling large joins and aggregations. So sharding can make performance large joins and aggregations across multiple shards very complex and slow, particularly if the data is distributed evenly or if the query spans multiple shards. So the impact of this one, joins and aggregations that used to be fast on a single database may now require fetching and processing data from multiple shards, introducing network latency and added complexity. The solution for this one, where possible, avoiding joins across shards, pre-aggregating data, or storing denormalized data can improve performance. Using data replication for common query patterns can also help that. Number 7, key selection challenges. So choosing the correct shard key is one of the most critical decisions in a shard architecture. The shard key must ensure even data distribution, align with query patterns, and minimize cross-shard queries. And the impact of not choosing the right key, a poorly chosen shard key can lead to unbalanced shards, frequent cross-shard queries, and performance bottlenecks. Once implemented, changing the shard key is complex and can involve resharding the entire dataset. A solution for this one, analyze the data and query pattern thoroughly before selecting a shard key, using a hashed shard key or a composite keys, or like combining multiple fields can be often help to achieve more even distribution. So number 8, operational downtime during shard failures. So shard failure or hardware issues affecting one or more shards can disrupt services for users whose data resides on the affected shards. And unlike the monolith database where a single point of failure is obvious, sharded system can have partial failures. And a solution for that, we can implementing a high availability mechanism such as replication, like a master slave or master master, or partition redundancy, ensure the data is replicated across shards and this can be recovered in the event of failure. Number 9, backups and data recovery. So backing up sharded database is more complex than backing up a single instance. Each shard must be backed up individually, and the restoration process must ensure data consistency across shards. Um, and the solution for that, we can use like automating backups and using distributed backup solution that handles sharded environments can simplify this process. Number 10, which the network latency and the communication overhead. So as shards are distributed across different machines, network latency becomes a significant factor. Queries or transactions that span multiple shards may involve high communication overhead due to data being spread out across different nodes. The solution for that, we can optimize queries to minimize cross-shard communication and use geographic distributed clusters only where necessary. Using caching mechanisms like Redis can help reduce the need for frequent cross-shard communication. And lastly, schema changes. So, in a sharded environment, schema changes must be propagated to all shards. If not properly coordinated, schema changes can lead to inconsistencies between shards or cause downtime during the migration. A solution for that, we can plan a schema changes carefully and test migrations in staging environment using techniques like schema versioning to apply changes gratefully without causing any downtime. So yeah, that's it for this video, and see you in the future.